Hi friends, this is Rakesh and today we are going to perform a steady state thermal analysis of a hollow sphere using ANSYS 15, right? For that, go for the preferences and select thermal because this is a thermal analysis, right? Press OK. What happens is that the selection filters out all the options that are not required for performing an thermal analysis, right? Now go for the preprocessor, go for the element type, and for this see this hollow sphere is an axisymmetric geometry. As an axisymmetric geometry, that is why we can model only 1/4 of the geometry and we can reduce the problem into say 2D by using the axisymmetric condition, right? For that we are going to use a 2D element called plane 77 for this analysis. So go for the element type, say add, edit, delete. Now go add 8 node 77 element, and in the options you change the element behavior from plane to axisymmetric. Okay, and close this one, and there is no need to put up the real constants. And now go give the material properties here. This is a steady state thermal analysis, that only convection, right? So we can only give k and div of all other material properties. So for that, go for the material models, go for thermal, conductivity, isotropic, and enter 200 here and press OK. Now exit the material model behavior. Now we are going to create the geometry. First of all, go for the modeling options, say create areas, circle, an annular circle, and enter in radius 1, which is going to be our internal radius as 0.02, and this radius 2, which is going to be an outer radius, which is 0.06 meters, right? And I want the center at 0 0, so I am leaving that two spaces empty. Okay, now we have to delete off all the other three portions from this area because we want to model only 1/4 of this area. So for that, you again go for key points, create some key points on the active coordinate system, and create one key point at the origin. So I'm leaving all the spaces empty, say apply. Now I'm going to create another key point at this end. So what happens is the x becomes 0.06 and I will leave other locations as 0 0 and I say apply. Now I am going to create a key point at this end. So we have to make this as 0, and in the x it translates about 0.06 distance and z 0 and press OK. So we have created all the required key points. Now join them by line. For that, go for lines, select lines, a straight line, and now you pick this and this key point and press OK and say OK. Now again select the straight line and select this key point and this key point and press OK, and again you press OK, and you have created two different lines. Now what I will do is, first of all I will divide this total area into two areas, and I will delete the remaining area. I will delete the remaining area which we do not need. For that, go for the operate, go for booleans, go for subtract, and go for areas, right? And you select this area because I want to divide this area. Instead of subtract, what we will do is we will going to divide it, and we will say divide area by line, and select this area which I want to divide and press OK. Now I'm going to select the lines which are going to divide this area, right? That we are going to select this two lines and press OK. And now if you see, go for the list, go for areas, you can see there are two areas, right? There are two areas instead of a single area. Now what I will do is I don't want this area, so I will delete this one. So for that, go for say delete here areas and below, and select this area and press OK. So what happens is the remaining area will be my one fourth of the part of the sphere which I want to model, right? So now I'm going to mesh the geometry. For that, go for meshing, go for mesh tool, say lines set, and say I want to pick all the lines, so pick all, and I want to give the element edge length as 0.002 and press OK. Now I'm going to create a mapped area mesh. So for that, select the mapped and say mesh, select the area which you want to mesh and say OK. So the mesh has been created. Now I have to apply the boundary conditions and other things. So as per the problem states that the internal temperature is somewhat 100 degrees centigrade, and this outside ambient temperature or the environment temperature is 20 degrees centigrade, and the convective film film coefficient is around 80, right? So we have to study the distribution of the temperature. That is what we are going to study here. So for that, go for the loads, go for define loads, apply thermal and temperature and on lines, and select this inner edge, press OK, and select temperature, and you enter 100 degrees and press OK. Now you have to apply a convective film coefficient and the ambient temperature on this arc on the outer surface. For that, go for the convection, say on lines, select this line and press OK, and give the value of the film coefficient to 80 and the bulk temperature value to 20, bulk temperature value to 20, and press OK. Now we have applied all the necessary conditions. So what we have to do is we have to solve. Go for the solution, let's solve. Say current load step, press OK. Okay, the solution is done. Now what we will do is we will see the distribution of the temperature from the inner surface to the outer surface. For that, go for the general post processing, then go to plot results, counter plot, nodal solutions, DOF solution, nodal temperature, and press OK. So it varies from somewhere around 100 degrees on the inner edge, because it is, as we specified, it should be 100 degrees, and it is going to dissipate heat, and after all the heat losses and other things, we are getting 96 degrees at the outer surface, nearer to the outer surface, right? And we can also plot this thermal flux vector sum using the counter plot. Now what I will do is I will specify a path, and I will show I want to plot the distribution of the temperature with respect to the radius in ANSYS. So for that, what I will do is, first of all, go for the path operations. I will say define path, and I will say by location, and I will give some name to this path, press OK. Now I am going to specify the first point number, and you see this is going to be our first point number, and so we have to specify the coordinates of that. The coordinates are in the x is 0.02, and in y and z it is 0, right? Press OK. Then again you are going to create the second reference point, and the x value is 0.06, and press OK. Now cancel it. So we have created the required path. So then what I want to do is I want to map all the results which I am interested onto that path. So for that, I will give some name like temperature 12, and my interest is the distribution of temperature, so I will leave it off like this and say OK. Now what I will do is I will plot my path items. Go for plot path items, and plot path items on graph, and you select the temperature 12 and press OK. So it has plotted it, right? We can also give the axis labels and other things from plot controls, style, graphs, modify axis, and our x-axis label should be radius which is in meters, right? And our y-axis label is temperature in degrees, at in degrees centigrade, degrees. And you see here, if you observe, the value of x is coming from 0 to 4, but we are interested in 0.02 to 0.06. So for that, what we will do is we will specify the range ourselves, right? Here in the x-axis specify range, you enter 0.02 to 0.06 and say apply and press OK. Now just right click and say replot. Now go to the path range options, and here in the path range options you give, again enter the minimum and maximum distance value, that is 0.02 and 0.06. After entering the value of 0.06, press OK and you will get a graph like this, which is showing the temperature in degrees on the y-axis and the radius in meters in the x-axis, and this is the variation of the temperature. Okay, and I am also interested in finding out the rate of heat flux. Sorry, it's heat rate. I am interested in heat rate. So what I will do is, in order to find out heat rate on different phases, I have to specify the element table and with specific codes, and this can be found in the element reference of the ANSYS help, right? And here we have to specify the commands 5, 11, 17 and 23. For that, go for the element table, say define table, say add, and give a name T1, let's say T1, and sequence number it's 5 and press apply. Then T2 sequence number and it's 11, so apply. And T3 a sequence number and 17 and apply. And this is some T4 sequence number with 23, press OK and close this one. Now say list element table and select all the four, and say T. Okay, now what you will do is you just say, because after adding all these things you will get the heat rate. For that, go to absolute, not absolute value of that, you can say sum up each item and press OK, and after summing up you will get Q equal to 138.134, and you see you have to multiply it with 2 because this is only for the half of the surface, and other half because this is an axisymmetric problem, you have to multiply it with 2 to get for the other half. So the total Q value is 138 into 138, it is somewhere around 276. So this is how you also see the heat flow rate, right? Thank you.